Okay, so I did remember to start recording. Great. Today we'll go backwards through the alphabet. So we'll start with Mr. Swift, who's not here yet, right? So we'll go to Elijah. You can go first. We'll back up and pick him up when he shows up. Oh, I gotta set it so you can share screen.
Yeah, I was just about to ask. So I just opened Unity to make sure that I can show y'all.
Yeah.
And apparently
I was showing particle lag in the 312 class. And when I run the particle lag thing, I flood the scene with 200,000 particles. And while with Zoom not running, it works. The lag is there, but with Zoom running, it just barely chugged. I don't know what it is about Zoom and Unity, but they're not happy together.
Okay, so I didn't break too much, so we're good. Okay.
So you can share screen if you want to.
Yeah, trying to get that set up. So where'd you go? There you go. Last week.
Remind us your topic each time here.
Yeah, so I'm doing the Portal kind of game.
Okay.
Portal puzzle game. So this week was much more productive. I was able to get because I wasn't happy with my character controller from last time, so I found a character controller that I really liked, and it's like there's so many like settings that you can like customize with, but the big thing is that it was a character controller for first person, but it still had some like animation.
Oh, cool.
Like ability, because before I couldn't find anything, so that's why I was trying to build it myself. But this one I found where I can hook up the animations, so when you see yourself in the portal, it doesn't look.
Did you have to buy it?
No, it was free. It was free.
Cool.
It's great.
Put that in your progress reports. We all want a copy of that.
Yeah, so you can choose either first person or third person, but it was good for my first person thing. So I was happy about that. I was able to use the animations from my last one as well. I'm still going to tweak it, but for now it's good. And then I was able to pull in a portal gun kind of asset. So I just got it working. I haven't. Okay. Well, it was working. We'll see. I think it doesn't like sometimes too many like seeing itself too many times. I don't think.
Great.
So like this works, but as soon as you like start doing the weird infinite mirror thing, sometimes it starts freaking out, and that's when it crashes. But so long as you don't do that too bad, and then I don't know where it is. Yeah, it kind of freaks out when you go into the ground. So I have to fix that because like the gravity of the player isn't exactly right.
So you're actually passing through these portals.
Yeah, so like I'll jump into this one and I'll come out over there.
Oh, right? That is so cool.
Yeah. So it looks pretty cool. I'm not sure why it's upside down.
Yeah.
So like it works, but there's some things I have to tweak.
Yeah.
And then I also, I was messing around earlier with like I want to be able to change the size. So because I'm not like the ovals are really big, but they're checking to make sure that the portals are placed on a surface like assumes that's still an oval, so like it doesn't place it like way down at the bottom like I want it to, because it's doing its error checking. So I have to do some fiddling with that to make these portals like the sizes that I want and stuff. Anyway, so it's progress, but I still have to fiddle with it a bunch to make
really
it like
cool.
I would like.
I'm very impressed, having fiddled with this problem myself and seeing that in action dynamically, and with the infinite regress there that you got when the portals can see each other. That's hard. That's great. Way to
Yeah,
go.
I'm still trying to figure out like all the code for that to make sure it doesn't crash, like limit it so it doesn't do that infinite so many times. I think there's a setting for that.
Yeah.
So I'm still trying to sift through the code, but pretty good for
Wow. That's
now.
that's fantastic. Any questions, comments, suggestions for Elijah?
I got a question. This is Apon. Did you try? Oh, I was just curious how it does with like, because I remember the Portal games. If you jump from like someplace really far up, you keep the
Yeah.
momentum. Does that work?
No.
Oh,
Like I didn't have time to set it up. It was in a different project that I had an object, but so yeah, you think I would like shoot out like really far, but you don't. Sorry, you don't. It like
Came out and went back in again, didn't it?
yeah, it like completely. It doesn't launch you out. So, but it seems to do good on like other objects. Like I had a rigid body object on a different project, like a ball, and I was dropping it through, and it seemed to come out like the appropriate amount. So it must be just something with the weight of my character that I have
yeah.
to fiddle with. Like maybe my character isn't heavy enough for whatever physics it's launching. So
That's cool.
Do you have an example of Devin here? Do you have an example of just throwing an object in? Because I'm actually really curious now.
yeah, no, I could probably do one. What do we need on this? We need a rigid body. And then we need one of the things to make it a portable object. And then maybe. So shoot. Okay. So, oh, I fell. I fell in it. How do we get that to work? I guess we'll just place it really high and try to place something under it.
Yeah.
I don't know how to do it quickly. I missed. Well,
That's great. That's
Yeah.
amazing. Oh, that's too funny.
so, well, if I were, had a perfect example, I could get it for you,
Oh,
but
actually, maybe a good example is just because I'm trying to think of my experiences playing Portal. Just place you could try to place a blue portal under it now and try to get it in a loop between the wall and the floor.
oh yeah.
Because if it breaks the loop, then well, that tells us a lot.
Oh, I can't aim.
Oh, it seems to be chugging a little bit.
Yeah, so it got some launching there. It's hard. Well, okay, there's the loop.
This is fantastic.
Yeah. So I don't know. There's a little bit of, because I changed the shape of the portal. Oh look, see, it got a little bit of force and it missed the second time. So the force seems to work on like other objects. It's definitely not the person.
It might just be something with the player controller then resetting itself, resetting its momentum.
Right. So I have to sift that to figure that out.
Okay, cool. Any other comments, questions, suggestions? Okay, unshare your screen there. Let's see if Mr. Swift has shown up. Forrest, you're here.
Yeah, I'm here.
You're next.
Okay. So I switched over this week from 3D to 2D, which I feel like was kind of a big move, but I got multiplayer working, so I feel that it was probably the right move. Because of the way I could actually pull up and show some of my scripts. Because of the way that I'm scripting with the netcode, I'm using like client controls versus server controls. Like server actually handles the movement, whereas client just kind of tells the server what it wants to do. And because I have to like program all of this stuff, it just seemed too complicated to try to recreate the 3D character controller. But I did host. Whoops.
What was your game again? I'm sorry.
Mine is multiplayer, specifically going to be like a multiplayer action RPG. So the things that I was working on this week, we're getting the characters to actually move and register each other on all 4 screens, which you can see they now do. As well, I also got this AI that checks all players in the game, anything tagged with a player tag, and sees which one is the closest and will target that person. So when I get closer, you'll see this guy actually looks at me. And then the other thing that I did, which is not working right now, is you see that the players all look at the mouse, but only on the server screen.
Okay.
When you try to look over here, they're still looking in relation to the server screen. And then another thing that I want to have by next week is to fix that, but also to fix, I want each of them to have a character that tracks your individual player, so that there's not one central camera. That way each player could be going and doing whatever they need to be doing in the world without interfering with other people's gameplay.
That's great.
That's about all I have this week.
So you're saying that all of the characters right now are sharing the same camera, and so that's what you want to fix next time? Is that what you're saying?
Yeah, so currently there's only one game camera. And the way that I think you're supposed to do it with netcode is you set up Cinemachine cameras, which are like virtual cameras. And then when the player loads in, their Cinemachine tells the main camera what, like, gives it a fake set of coordinates that it's supposed to be pretending that it is at for that player. It worked out. I saw it working in the 3D multiplayer demo, but I haven't actually tried to mess around with it too much. I tried a little bit, but it wasn't working too well.
Okay, well, that's great. And I think, this move from 3D to 2D is not a bad idea, since the main thrust of your topic is multiplayer, and all of those 3D animations and so forth are just, gravy. But
Yeah.
that's great. And I like the little eyes that
Thanks.
turn and look at each other. Great. Any comments, criticisms, or suggestions for Mr. Swift? No? Okay, Roshan, Ms. Rumsey, are you here? I don't see her. Okay. Peter Reel.
Great. Yeah, so last week I didn't make much progress, but this week, fortunately, I was able to start getting the ball rolling on a lot of my Unity stuff. Let me just share my screen here. I think you guys should be able to see my Unity now. So first thing I did was in scenes, I just created my last 2 maps. I also went ahead and played around some particle systems. So I have a rainy road now, which is right here. I tried to do bridges, but with the free version of Easy Roads, you can't do bridges. So anyway, I just have like a little bit of a lake there that you drive by, and it's pretty cool. It's a pretty cool map. Also, I added some more detail with some of the map. Hopefully you'll be able to see some of the stuff gets weird with the, well, whatever. Here's the rainy map, and here's the hilly road. This one as well. I think I have it in this ISO. Yeah, I need the perspective. So here's the hilly map. This one, it has some pretty steep inclines. I had to play around, of course. It wouldn't be easy roads without some serious problems. So when I create the road at first, sometimes if it's too far off the original height map, it'll pull the road, it'll pull the height map to the road instead of adjust the road to the height map. So you end up with these really strange, like if you could see it here, it looks like it almost creates like a little bit of a bridge with the terrain. So playing around with that and trying to get that all right was a pain in the butt, but I ended up figuring it out. So anyway, those are my last 2 maps. Also with the snowy road, I have a particle system that creates snow. You can't see it now just because of, just I don't have the camera in, but anyway, it's the same with the rainy road. There's a rain system as well. It just makes it look like it's raining. I'm still playing around with those, but just trying to add some immersion. Anyway, most of the progress was done though with playing around with the cars. The Unity car is good, but there's only so much it can offer you. A lot of the scripting is kind of weird, and it's hard to reverse engineer it to try and figure out what they're doing. So I just started playing around with some of the scripts myself. If I open up my car, sports car. So here it is. I added the camera object now, so you have the first person perspective. It's based off of Forza's perspective. So I just like booted up Forza real quick on my Xbox, played around, and copied the exact camera model they had. They have a dynamic camera, so it shifts when you turn. I haven't figured that out yet, but hopefully if I get the car mechanics, that could be something cool I could add. Anyway, I've started creating this script. Let me find it here. Car controller. I think it's gonna boot up on my other screen. Maybe I could pull it over to this one. You guys can possibly see it. I don't know if you guys could see my Visual Studio right now.
No, we can't.
Okay, let me see. You share. You guys should be able to see it now, I think. Anyway, so I've started creating my own script just to move the car. I've been watching a YouTube video that it's loosely based on. He does it interestingly, where he's just kind of moving like this weird car thing he made. I'm more trying to tailor it toward each individual car and also make it so that it's transferable from car to car. I want each individual car to have their own car controller. I don't want one universal car controller. So I'm trying to make this like as transferable, I guess, as possible. So I'm loosely basing it off that. I'll link that in my progress report. But yeah, here's the code I have so far. I could go into great detail about it, but pretty much like I have a method that gets the input from the keyboard. This is going to handle, the acceleration, turning. It's just going to pretty much be a WASD game or an ESDF game, one of the two. And then this handles the steering for the car. This adds the force to the wheels depending on the user input. So this takes the vertical input and just multiplies it by this motor force, which hopefully, like, that's something I added in, where hopefully depending on the car, if you have the garbage truck, it's not going to have depending on the weight, I can adjust that. And also, the sports car is going to move a lot faster than the garbage truck. So with this motor force, I'll be able to do that. It's a nice multiplier that gives me a lot of adjustment over the individual cars. Anyway, I have the brake force. Each individual wheel has their own brake force. Doing this is really going to allow me to give, like, depending on the front wheel drive or rear wheel drive or all wheel drive of the car, this brake force is going to be, I think that, I guess, dipping this up into each wheel, it's going to give me a lot greater control over the physics of the car, depending on the speed and acceleration and the actual weight of the car, and front wheel drive, rear wheel drive. So this here, and then update wheels. This is just going to update the wheels. This kind of just handles the wheel visuals if it's turning or if it's slowing down or what. And I was trying to play around, like I said, with the Unity stuff. The Unity car is just, I don't really know how to say it without being PG-13, but it's weird. A lot of the code is weird. The scripting's weird. The sound is weird. So I was originally gonna, do stuff off that, but it's just too hard to figure out, honestly, and it's not really worth my time. It is nice to look at it to see how they break up a lot of the scripts and how they combine all of it and bring it together with the car. But they're just doing a lot of stuff that isn't necessary. In a lot of ways for me to try and reverse engineer.
So some time ago, one of the things the Unity car has is that steering helper, which, as near as I can tell, is kind of an anti-sway bar sort of thing. And this is something that, physically exists on real world cars, where as you corner and the car starts to lean, the sway bar, it puts more downforce on the inside wheel.
Right. Yep.
And I can't point you to it, but if you search for Unity car anti-sway bar, you might find the tutorial that walks through how to build your own.
Okay.
I found it once, but I did it, but I don't remember where I found it. And of course, my note keeping is kind of chaotic, so I've
Yeah.
lost that information. The other thing that I've noticed about the cars is that the force contact point is critical in defining the kind of handling that your car has.
Okay.
I believe the default is at the bottom of the wheel, which is kind of the physics, the correct physics of a car. The force is applied where the wheel touches the ground.
Yep.
But this produces a car that tends to tip over.
Right. Yeah. A lot of the force.
And so if you move that contact point up to the middle of the wheel or even to the top of the wheel, your car suddenly gets a whole lot more stable.
Okay.
And the other setting that you can play with is the stiffness, which is a quick and dirty way to scale all of the friction settings on forward friction and sideways friction. That
Right.
stiffness just kind of multiplies all the values. And so if you turn it from stiffness 1 to stiffness 2, suddenly your car is more sticky. And it's an easy way to change things. So that's my experience with the cars, is that the contact point's critical, and the stiffness is an easy way to modify friction settings without having to go through and define 4 different numbers. And the anti-sway bar, as I recall, really works. I mean, I went through the tutorial and I had a car that no longer tipped over.
Okay. Interesting. Yeah, I'll be sure to check that out.
Yeah, have a look. Okay,
Yeah,
that looks great. And I know the Unity car is a beast, but it's free.
Yeah, it's interesting. I booted it up. I don't know if you guys could see. I tried to share my game again, and I made a scene where I imported both cars and I played around with them. So I was using mine along with theirs, and it's this car test scene. And their car, honestly, it's like skating a little bit. The audio is really weird. It's always for some reason burning out. I don't really know what that's about. So yeah, I don't know. I'm trying to loosely base it on theirs, and yeah, it's a beast.
Are you going to have audio? Are you aiming to have engine?
Definitely, yeah. I was trying to do it with theirs. I mean, I could try playing this quick if I disable my car, but it's always burning out. The sound is just terrible.
Yeah, there is in the wheel colliders, there's an RPM read only that tells you how fast the wheels are turning.
Yeah.
And you could use that to control your motor sounds.
Okay.
Yeah, cool.
Sweet. Yeah, that's about all I got for this week.
Okay. Any comments, criticism, suggestions for Mr. Reel?
I have a question to say upon.
Hey,
Does
Pon.
your car work right now? Like, is it drivable?
Unfortunately not, no, it was, but I started playing around with the code again. And if I actually go to my car, I don't have any of the, so the way it's broken up, if you go into the inspector with my code, like it expects wheel objects in each one of those parameters. And right now, no wheel objects are assigned to the actual variables from the code. So unfortunately right now it does not drive.
Yeah.
Gotcha.
It looks like the scripting looks like it'll drive, but we'll see the demo next week, right?
Yes, I haven't drag and dropped anything yet. So no.
Okay. Any other comments, questions?
This is Dorothy Harris. Maybe you've said this before, but are you going to have like the rainy road or like the snowy road be slick and then like harder to drive on?
Absolutely. Yeah, that's definitely something that I want to explore with these different maps, is like, car physics in these real world environments. So absolutely, with the snow and the rain, there's going to be, depending on the turn force and the speed around corners, like, yeah, there's a greater likelihood that your car starts slipping. And then possibly on the rainy road, definitely like hydroplaning is something I could get in there. If you're going a certain speed, turning becomes a greater challenge, especially on straightaways. Your car could start, skidding out, or the back end could start fumbling around a little bit. So yeah, absolutely. These different maps that implement different weather conditions will certainly have an impact on the car physics.
So
All right.
I've never fiddled with it, but colliders all have physic materials. And the physic materials are designed to interact with two objects. And on the physic material, you have a setting where for each of the different properties, dynamic, static, and bounciness, whether you use average, minimum, maximum, or multiply. So, those like a bouncy setting of 0.9 on one object and 0.3 on the other, you can either use the average of those two, or the minimum of those two, or the maximum of those two, or the multiply of those two.
Yeah.
So, when you might be able to easily adjust the behavior of a particular road by just putting a different physic material on it and having the appropriate physic material on your tire as well.
Okay.
I don't know. I've never fiddled with the physic material on a wheel collider, but the whole idea of the wheel is slip. That's where the force comes from. As the wheel contact point with the road doesn't match, that's slip, and that slip produces force. That'd be an interesting avenue to pursue, making your different surfaces. And that way you could have, like, if you could actually do it with the physic material, you could have a portion of the code that had a patch of ice on it, that was like real slippery.
Yeah.
And you wouldn't have to fiddle with the car physics at all. You would just fiddle with the road physics. That might be cool.
Yeah.
I'd be interested to hear if that works, because I've never done it, but cool. Any other question, comments, suggestions? Racing games coming along. That's great. The worlds look good, and you're wading into the physics, so that's cool. Any other comments, questions? If not, unshare your screen, please. Okay, Mr. Howe, are you here? How? I don't see him. Not here. Matt, you're up. Harzuski.
All right. Let me share my screen here real quick. Stop. Unity World. Okay.
This class is the most demo-oriented class I've ever had with 415. You guys are great, and this is the best way to demonstrate progress, is to actually show working things. So that's great. Okay, go ahead, Matt. Sorry.
Oh, it's all right. I don't have a lot that's going to look different. It's mostly under the hood changes. The video I'm following right now focuses on recalculating the normals of the mesh so that they will be closer to the ones on the next chunk over, so that they will eventually be able to line up better. As it stands, it actually has made them look a little bit worse, but I'm told that later on in the series it corrects that. Some of these ones, like hill ones, get really bad. But what it's doing is it's like actually the noise overlaps between the chunks so that they will fit together. It's generating out beyond the original boundary.
Is that seen a difference in LOD?
Yes, yeah, it's the LOD
Yeah.
ones that are getting messed up. But if they're like if they're the same LOD, then they will line up perfectly.
So when you say you're not recalculating the normals manually yourself, you're using the mesh recalculate normal.
No, it's actually using a manual one instead.
I think I'm going to do something later today that maybe will help with that. I'll show
Okay.
you something when I do
Yeah.
my demo, but go ahead.
Yeah, so that's in progress. It seems to work pretty well on the interior ones, but the LOD changes is where it gets messed up. And I'm told that there's like a later video that addresses that, but so far it's progress anyway. And I also, just as an aside, I benchmarked casually the speed, like the frame rate it maintains while you're like flying the camera at like 100 meters per second or whatever the unit is. And it's maintaining like 200 frames per second while it generates chunks out ahead of it. So
Good.
it's definitely working pretty well on this. Is like a 2017 MacBook Pro, so it's not like super phenomenal hardware either.
Cool.
So
That's great. You know, the LOD issue is I don't know what character you plan to have in this world, whether it's going to be a walking around character or a fast flying airplane. But if it's a walking around character, your LOD is always going to be the same when you get to a seam anyway. So it's not going to be an issue on
yeah,
a ground-based game. And the fudge I use with the airplane in this procedural world is fog.
yeah.
You just make the distant terrains fogged out anyway.
I may do it anyway, just to
Yeah.
look nicer. But yeah, mostly walking. I want to have like limited flight, so you can like jet pack around or something. So you have like some sort of like resource you need to acquire to be able to do so. It's like my eventual plan.
Yeah.
Give you something to like a reason to explore. But yeah, that's about it. Anyway.
Okay. Any questions, comments, suggestions for Matt? Do you, I know procedural terrain is the big topic here, but do you have any idea what you're going to do with the procedural terrain when you get it? I mean, is there any plan for?
Yeah. So I want there to be some sort of like enemies that like chase you around or whatever in it, which is going to be a little bit of a challenge because I'm not sure about like generating not being we use pre-generated navigation meshes. I can definitely fake it with
If the advanced nav mesh package that you get from GitHub has all the tools you need for procedurally generated terrain. They even do things with their demo even does things where it just generates a local nav mesh. Like it doesn't bother doing the entire terrain. It does it just around the character, I guess. And they have a little point and click game, and you can point and click, and you can see it generating the nav mesh as the character moves out around. I don't know how they do that, but it's in their demo. But
advanced nav mesh.
what's that?
Advanced nav mesh, you said?
Yeah. I don't think I've done it yet in this class, but if you look on the YouTube for last year's 412, there's probably one of the classes is for that. I'll do it at some point, I think, but I haven't gotten around to it yet.
All right. I'll look into that probably.
But yeah, there's a nav mesh package that does you can make an object that is a nav mesh surface, and you then have control over it at runtime. You can bake nav meshes at runtime. You can add links and do all kinds of stuff with it that you can't do with the default nav mesh. But yeah, it's exactly what you need if you're going to have AIs who need to navigate on your procedurally generated world. That'd be cool.
Yeah,
Okay.
that's basically the idea. That and then collect resources so you can fly and avoid those enemies better, basically.
I'll send you a link. Let me
All
write
right.
this down.
That'd be
Send
great.
Link to NavMesh. I'll try and remember to do that. Okay, any other comments for Matt? Okay, Dorothy, Ms. Harris?
Sure. Let me share. So there's not a huge amount that looks different necessarily, but I did get somewhat of a saving character method to work. It didn't do it the way I wanted it to work, but it did it a way that works. So that's what we're going with. If it
Was it,
okay.
was it something in the applications class?
It was, so I was looking at a tutorial originally to do it, and then I looked at something else, and I kind of mixed the two, and then also had to just look up my own like Unity commands to add in. It was having problems with, so like I can, right now, things still work, they move things around, except I think my background's hiding one of the legs, but that's fine. I can fix that. And when I submit it, I actually have the character here, which before it wouldn't submit it. The problem is that I was seeing is that, well, it's kind of a problem. If I go back to the test scene and I like restart it, the starting character is the one you just picked again. Do you know what I'm saying?
Yeah.
Which is not necessarily a problem because you'd only technically do this window once because it's the beginning of the game. But if I go into like the game scene and you start it up, it does the one you picked. So
Yeah.
it was a lot of fiddling with to get to this point.
So I wonder if when you start your scene, it could clear the character, you know, could,
Yeah.
like in whatever the prefab is saved as, it doesn't matter. When you start the selection menu, it goes through and basically sets the character to the base picture that you want with no hat and no boots.
Yeah, I can do that.
Maybe.
That might help. And
Yeah.
then the other thing I've been looking into is the next thing I want to kind of work on is I want to make in the actual game things that you can pick up and put on. And then that would be like a little inventory menu. But then I realized I was like, well, I probably should work on like actual background and like a scene that you can move around with before I start making things you can pick up. So I was looking into the free assets and also ones that you could pay for. And this is one of the ones I found. I'm not hugely a fan of it, so I'm kind of fiddling with different things right now. I also think I want it to be top down, kind of like which requires me to make more views, such like a up, down, left, right view. But I don't know. That's where I'm at right now.
So did you get there's a 2D game kit that Unity offers that I think has a lot of 2D stuff.
I don't have it, but I can look into it.
Yeah, I think it has, if I recall, it has a lot of stuff, scenes and trees and other kinds of assets you can use in a 2D world. Okay, well, that's good. Any questions, comments, suggestions for Dorothy and her duck?
Differential here. Actually, what was just said, I was looking for it last week, Professor, after you mentioned it to me. I actually couldn't find it on the asset store. I don't know if I was just typing it in wrong, but if you do find or anybody finds it, please.
What is it? You couldn't find the 2D game kit?
Yeah, I couldn't find the kit.
Okay, I'll look.
Oh, that would be great. Thank you.
I thought there was one.
Devin here, maybe it's deprecated.
Yeah, that happens. If so, I might have a copy of it. Okay, any other suggestions? comments, questions? No? Okay, so we move to page 1. Mr. Hallett. Hallett. There you are. Okay.
Hey all. I don't have too much to show this week.
Remind us what your game is.
Yeah, I'm working on like just procedural generation, landscapes and stuff like that, and particularly trying to make like a sphere. So like spherical planets, all that kind of thing. And this right here is basically like it's just from a tutorial by Sebastian Legge, and it's basically just like a copy and paste. I haven't gotten a chance to sort of like really engage with the code because code is pretty intimidating actually. But when you just run it, it's really pretty awesome. It uses marching squares and has a really nice interface. At least all these wonderful exposed variables. Let's see.
So is this,
yeah,
that's great. Is this the terrain that you can actually have caves in?
yeah. Yep.
Yeah.
If you,
Okay,
there's
that's
another
very cool.
Yeah, there's another scene where you can run a submarine.
I've seen that one. That's great.
Yeah. But there, I can link to the tutorial.
The thing
pretty
that's
much-
great about this approach, like our traditional terrain model is an XZ plane that has height. And that's it. You can just specify the height, and that makes a surface that undulates over that height. But with this marching cubes algorithm, it's a volume thing. And so you can have overhanging cliffs. You can have, you can see them there, that those mountains are kind of leaning to the left. But that's really cool. And you can have bridges and other kinds of structures. So that makes a very interesting terrain. And that's Sebastian Legge, right?
Yeah, or yeah.
Cool. So you've been through that tutorial and got it working. Of course, he gives you GitHub stuff, so the code just, drops in your lap, right? Now all you have to do is learn how to use it, which is no small task. So I had one student who did this kind of thing a couple of years ago, and the thing that he adapted was that your character could modify the terrain as the game was running. And so he could reach out with his pointer and grab a piece of terrain and drag it and make an arch that would go across. And that was pretty cool.
Yeah.
I don't know how it worked. I don't remember, but being able to sculpt the terrain while you're walking on it is a pretty cool tool. I don't know what direction you're going. So yeah, and I'm sorry, I didn't mean to interrupt. Go ahead. Anything else?
Oh no, I don't have too much to say today. I mean, I've been a little bit stalled on this project. But I don't know. This is I think marching squares is there are a lot of it's very expressive. There's like a lot of parameters. Oh shoot. Let's see.
Yeah, crazy.
And it's cool because you can kind of see like what I don't know, like at the different scales, you can kind of see like what's like what the geometry stuff going on is. So I don't know. Yeah.
It's a wonderful tool. You can have fun with that. I can imagine all kinds of weird stuff with that.
Right.
So any comments, questions, suggestions for Will? You can stop sharing your screen if you want. No.
Yeah, Peter Kluge here. Do you have any idea of like how you're going to navigate the terrain? Will you have like a character running around? You have like enemies or something like that?
Well, what I wanted to do, I just wanted to do like a work as a visualizer.
Okay.
So more just sort of like figuring out what the interface is, and what's it sort of like, I guess you could say like user interaction is to sort of like modulate those parameters, and then what the sort of like story is about modulation of those parameters. So a little bit less of a sort of like standard gameplay and more of like I guess a different kind of, still on that sort of SimCity gameplay style, not necessarily like a FPS or something like that.
So you were saying you were wanting to do like spheres, right? So like, I guess you're like in the universe looking at planets and changing it and making it look differently. Is that kind of what you were saying? Like, okay.
Yeah.
Because it does seem cool to be able to be like in the universe looking at these planets and like changing and like seeing them, I don't know, morph to your input.
Definitely. I mean, I think like programming animations, it was like would be a really nice way to sort of like dig into this code. But yeah, like the morphing and stuff. I agree.
So having user controls in the running game that allow the user to access those settings of the terrain generator so that they can actively change the lacunarity and pop up the number of octaves and stuff like that. So that, I mean, because it's one thing to fiddle with it in the editor, but you're not going to be able to sell the editor for people to run the game in. You have to have the controls in the running game that modify the settings of the terrain generator, which I assume you can do. I mean, you know, those are all just settings that one has access to from a get component kind of thing.
Yeah.
Okay.
Yeah.
Cool. I like it. I like it. Any comments, questions, suggestions? If not, we'll move on to Mr. DeFrumolo. Where are you? There you go.
Let's see if me not using my camera helps me at all. So this week I really wanted to focus on starting the dialogue and seeing what I could do in terms of like starting quests with it. Safe to say I did a terrible job. I was kind of going through the ringer on it. Here, let me. So I'm having an issue with actually getting the text to activate a quest. I'm pretty sure I'm missing a component that when I watched the video of the actual designer of it, he uses something in the assets didn't turn over. So I'm trying to look for that currently because I need that to start a quest. Where this is right now, I can show this. This is just the conversation I started with the character in this room. Basically, you're just going to go find something. I haven't really fleshed that out. I give 2 options, and both options ended. You're going to have to go find it anyway, which is kind of what I want to do. I want to make it funny, and you're going to have a lot of options of what you want to say. Maybe not have a choice on what you want to do, though. So that's what I kind of have right now. I definitely want to figure out over the weekend where my issue is going awry on why it won't activate the quest. When I was there should be something in the set that I am missing.
Okay.
To show something new I created, I'll just run through some of the scenes I was working with, just to give you guys something. That scene. So Yep, I'll say that. Just a couple of rooms and different types of hallways that I'm going to let the character be roaming through. And one of the next things I want to do is work on connecting them. So either setting a collider to a door to activate changing scenes, or to make it a fluid house, so it feels like you should walk through the house. Yeah, so within the next week, really want to get the dialogue down, because once I can get the quest going, I can connect the house and it'll all work in. And that's my last. So I have one little one. No, it's so yeah.
Okay, the rooms look cool. That it's a refrigerator, of course. Yeah, that looks great. Where'd you get these assets, or did you make them?
It's actually a mix of a lot. So one of the things I use, the walls all come from one. It's I think it's this one, right? Yeah, Mucho Pixels is the asset. I think I bought that one. That just gives me a lot of like the doors and the walls, and these sprites themselves, I think Polymesh World, maybe. I think so. Won't open for me. Yeah. It's one of these. Yeah, this is definitely the walls and a lot of the interior. Like, I think the couches are from that, and then this would be some of the rest of them. Like some of the, I know the fan and the lights up here and the oven. That would be I can't think
Great.
of this.
I like
what
it.
that would be called.
Some fire particles coming out of the top of the stove would be a good idea. Okay, any questions, comments, suggestions for David? We're seeing some chat here. What's the chat saying?
A hood. Thank you. Couldn't think of the
hood.
word.
A hood.
Kitchen
Okay.
hood.
All right. Any comments, questions, suggestions? If not, we'll move on to Peter Kluke.
Hello. Yeah, okay. Share my screen here. Let's do this one. All right. So last week I didn't really get a whole lot done, but I've kind of tried to make up for lost time. I've been trying to familiarize myself with the terrain toolkit API. It's been a lot of fun. I've spent way too much time on this.
Yeah, I know. It's a time sink, isn't it?
You kind of just get lost in it, just playing around. But basically, I've created a whole bunch of different scripts. So I have one that basically, once you start the game, it basically does an auto generate where it resets the terrain and then does like a purlin noise, creates all these like mountains and stuff, uses erosion to kind of smooth things out, uses regular smoothing techniques. And then if I just hit play here, it should reset everything. And then usually takes a little while. There we go. Can I airdrop
You went
you
in and you're modifying the toolkit yourself, or this is built on top of their API?
Pretty much just built on top of it. I've been kind of experimenting with a lot of things. It's not perfect yet.
Yeah.
I'll just try this again. Sometimes it generates too high up and it doesn't generate the objects. So I'm kind of tweaking some things as I go along.
The character falls through.
Yeah.
Yeah.
Okay, that's better. So the other thing that I've been doing is basically I created a generic kind of object placer script. You can kind of put any kind of game object into it. It'll basically place randomly all these different objects around. You can also kind of put height caps on it. So for instance, the little palm trees won't generate above, a certain height in the world, but the conifers will.
That's cool.
Yeah, so that's one thing I've been working on. I also made a variant of that called Object Cluster Placer, which basically it places one and then places a bunch of little ones around it. That's one I'm still kind of working on. It's not perfect yet. But yeah, pretty much I've just been building these scripts, experimenting a little bit, familiarizing myself with the API.
Well,
Having
that's
a lot
very
of
cool.
fun.
The toolkit, the fact that they give you access to all of this procedurally so that you can use their tools to sculpt terrain, and in particular texture terrain, doing that procedurally is pretty cool. But this object placement, I don't know how you're doing it, but that's really important for a procedural world, is being able to populate it with stuff. And since it's procedural, you don't know what's going to be there when you throw the random numbers. And so figuring out how to do that, that's great.
Right, and I kind of
definitely like this height limit thing for, palm trees at low elevations and conifers at high. That's a very cool idea.
Yeah, I definitely wanted, I knew going into the object placer, I definitely wanted to do it like any kind of object rather than like limiting it to like just trees or, specific kinds of objects. I figure I can use this
a
for
raycast with that? Is that?
No, actually. So if I hang on, if I can pull up Visual Studios here. Can you see the Visual Studios?
No, we can only see your editor.
Okay, hold on. If I stop sharing and then I can reshare. There we go.
We see it now.
So basically, it just generates random numbers, grabs like the terrain position. So it is like the X coordinate with Z coordinate, and then grabs the Y coordinate.
Mhm.
And then just generates a new object there. One thing I've kind of been running into though is that it really does that during like the update. Because if I do it during the start, it'll just take way too much time. So I was thinking if there is a way to do it like faster. I've kind of been stuck on that. Like I don't really know exactly how to speed up the process of placing down objects.
I don't know, the job system.
Yeah, maybe.
I don't. So you're instantiating objects, and
this was actually code I got from
slow
a
for the
uni forum.
start function, because the start. I'm surprised. That the reason I asked about the raycast is some have you randomly place an object somewhere high in the sky, and then you raycast straight down from that to find a hit point, and then move the object to that hit point. I have no idea if that'd be faster.
Yeah, it's definitely something I want to look into. I think it just needs a little bit more like testing and stuff.
It may be, it may be the terrain sample height is expensive, and that it has to look. I don't know. I have no idea why that would be slow, because it's just a couple of random numbers. I don't know. Put the profiler on and try and see where this is spending its cycles.
Okay, yeah, that's a good idea.
Any suggestions, comments, criticisms for Peter? That's a good job. I mean, wrestling with the Terrain Toolkit API is definitely.
It was very tricky at first. I ran into a lot of problems.
It's a lot of options, a lot of arguments that have to be filled in, and decisions that have to be made. So cool. Any comments, questions, suggestions?
Oh, I see a question in the chat about what kind of game. So this is just going to be like a survival kind of adventure game. I was thinking of maybe doing procedural generation. I'm not entirely sure about that now. Maybe just having like a limited terrain size, but randomly generate every time you play the game. It's something I'm still kind of considering.
The one I always wanted to do with the API toolkit was have the erosion or the wind or something modifying the terrain while you were playing. So
in
it-
real
it
time.
made
Yeah.
a pretty serious hiccup when I did that, so it didn't work. But anything else? All right, Devin, you're up.
Okay, so this is a slow week for me, so I have nothing to show at the moment. That my big demo reveal for this week's progress is probably gonna be next week after the progress report. I'm
Remind us
currently
your topic.
I'm working on the little FPS project of trying to have like cool AI enemies and being able to interact with them in unique ways. Currently I'm just developing the UI for it, as well as trying to get a very hostile cylinder named Steve that'll shoot at the player. Um, work in progress. It's proving to be a problem.
Okay.
Yeah.
Any comments, questions, suggestions for Devin? All right, well, continuing on, Mr. Campbell. Campbell. I don't see him. Okay, so Abby, you're up.
Okay, so I'm doing the geocaching in a forest game. I also don't have anything to show for this week. I just didn't have a ton of time to put into it. My main issue that I was still trying to work through is my eternally spinning joystick. I tried to do a little bit more research on it, because again, it seems to be kind of a common problem. I didn't get any terribly straightforward answers other than stuff we already talked about last week in class. But I'm going to try to at least get the joystick working by the end of this weekend.
Okay, cool. Yeah, that's a struggle. Anytime you're making your own controller, it's a struggle. Any comments, questions, suggestions for Ms. Boucher? No. And finally, pride of place, Donato, you're up.
All right. Let me just share my screen first. So I'm making the turn-based combat game with like the randomized map, and I wanted to be finished with the combat this week. I am very close to, and I think I'm just gonna start moving on to the next part because the rest of it's more balancing and then some little things. And I don't think I can do those little things until I get the map ready, because a lot of it has to do with like the random encounters you can have, and I want to make sure I understand the map well enough. And I'll explain that in a bit. But for the combat side, most things are done. I never actually I tried to make it so you could see the enemy's health bars and stuff. Oh, I actually want to make this full screen. Hold on. I wanted to make it so you can have the enemy's health bars on the screen, and I really tried getting that working. But I couldn't figure out a way to make it work with the way I have it right now, because right now I just threw these guys on the screen with no particular like spawn points, and my plan is, once I get the randomized map working, is that I can have certain spawn points for these characters and then just plop the health bars for them like in the same location but on the canvas I have for the UI. But
I can, with the canvas,
mhm.
it can be in the world. And you can make the canvas a child of your character. And then its positioning is relative to its parent, the character. And so that canvas will stick with the character, will be wherever the character is. So you actually make the canvas, the UI canvas, a child of the character. And then all of your positioning of that world-based canvas is relative to the character.
Okay, so if I put one like on one of the little red guys here, it, no matter where I put it, it will stay relative to them. That's actually really good to know, because
yeah,
I was just gonna be like, okay, if this is the spawn point, I guess I'll line it up like that. But that makes it a lot easier.
No, it
then
is.
you
It's
can
much
randomize it.
easier. You make the canvas a child, and then you can put all the different scripts and everything that make the sliders move and do all that stuff. Works exactly the same way it does with any UI element, but your UI is locked to that character. This is how a lot of those little sliders that are above characters work. You know, if you've got a little slider above a character that's got a red green health bar that's declining with time. Yeah, that'll work, and it's pretty simple too.
Okay, that actually makes that a lot easier. So I'll most likely have that done by next time. But right now what I have is I made it so there's 2 enemies here because I wanted to show off that I made it so you can select your enemy. So first character I have here is Horus. I can choose which one I want to hit. Right now it also tells me that one of them did hit one of my characters. And you can see like it actually affects them. But that should work. There we go. So you actually do have to select it every time you pick a character, and I try to make it so it actually deletes the arrow, but it doesn't seem to be doing that. I'm gonna have to check that up again. It's like a weird bug. I wanted it to make it so that the arrow would be just gone after the next character is ready to go, because it makes it very confusing why the attack's not working, because it requires you to select an enemy every time. But that was one of my other issues. And then I decided to start on my map creation, or the randomized map. So I found this perfect thing. It was on GitHub and it's pretty much all complete. I do have to like mess with it a little bit, but it's based off the game Slay the Spire, which is exactly what I was basing the whole idea of this game. You can't see it here, but if I press, well, I could show you real quick here, this map object, which has all these things I can customize, like the nodes, if I wanted the orientation of the map to be left to right, and then I can change the map manager, which has the configuration of what's in the map, which is really cool. So like, I'll just go into that, but it just lets you tell you the map, like I want this boss to potentially come up, I want a store to potentially come up, a treasure room, any of these things, and you can make it set to specific layers, have specific things. So I always have a boss at the end. This is the default right now because I haven't had much time. I just found this yesterday, so I haven't been able to mess around with the core of how it works.
That's a great find. Be sure and provide us with links to that in your.
Yeah, it's really cool. And like there's a YouTube video with the guy explaining it, and he explains the only thing you really need to do. Oh, actually, it's saved what I had last time. So let me just because I was trying to see how it would work. But if I just quickly start it up and then where is it? Generate. Here we go. So if I generate it, it makes a brand new map every time.
Oh, wow.
It's really cool. You have to generate it while you're playing, because when I wasn't playing and I clicked generate, it didn't destroy the previous map, and so it really bugged out the game. But I don't think that should be a problem really, because it should just reset, and it saves your progress for where you are too, which is really cool. But it's a really cool map and I like it a lot. It's exactly what I wanted. I might change the little nodes, the little icons, to make it more match my art style. This is the art style that the guy had. He said he got it for free. But he was doing the exact same kind of game he was basing off of, and I was like, this is perfect. It lets you customize it, you can change the way that works, and the only thing I really need to add on it is, well, an understanding it, and two, making it so it actually,
understanding it.
yeah, that's one of the big things.
No,
And then,
I'm not, I'm chuckling, but not.
The other thing I need to do,
any powerful tool is has a learning curve. you
Yeah.
know. Hammers are easy, computers are hard.
Yeah, exactly. And like the only other thing besides, once I get that, is I need to make it so that it actually does something when you click the rooms, which he has like a whole section of code that's commented that says here's where you'll need to put the like scene transition. So if I hit this guy, goes to an enemy encounter, which I can set to be, it can pick maybe from like a random set of enemy encounters. So I don't want to make it completely random because you might get really unfair enemy combinations or something, but like you could either get two of those red guys or like some big guy or two medium guys, something like that. But I was really happy when I found this. This saved me a lot of time. It's just really good overall.
Very cool. Matt says that we must remember that a computer is sand that we tricked into thinking. That's pretty funny. All right. Well,
yeah, that's it.
Any comments, questions for Donato? Stop sharing your screen. Any questions, comments, suggestions? Now we're all worn out. Okay. Well, my turn then, I guess. So let me clean this up a bit. So I like physics. And one of this actually started as an assignment in computer modeling, COS412. And you know, I did all the homeworks in Unity, and this was one of them. And we can make waves by connecting a chain of masses together by springs. So we've got these masses and we have springs connecting them. We have the positions of these things. And so for an object, for one of these objects, it's seeing two forces, the force from the right and the force from the left. And that's just basically its displacement from its own position relative to the position of its neighbors, the length of that spring on either side of it. And so this is a differential equation. F equals ma basically is what we're looking at. And so a, which is second derivative of position with respect to time, is going to be this k over m, and these little, and just combining those terms, you get this kind of funny I minus 1 minus 2 ui plus ui plus 1, the positions on either side. And this turns out to look a lot like a central difference approximation of the second derivative. I'm not going to show where that comes from, but what it means is that we can replace that and we end up with a partial differential equation, which is a function of both position and time. And this constant term in front here turns out to be the velocity squared of a wave that travels along such a chain of masses. And we can solve this using the machinery that we've seen here, where we take second derivative equations and turn them into two first order equations, where the derivative of velocity is acceleration and the derivative of position is velocity. And so we solve these two instead of this one, because that second orders are hard. So various numerical methods, Euler, Euler-Kromer, and Euler-Richardson, which is one that I use. Euler-Richardson, what it does is it advances half a step, and then it uses the slopes at that midpoint to advance the whole step. And so we have two evaluations of the acceleration, which is the expense of this thing, and that's a higher order method. I'm not going to go through the analytic solutions because I'm sure that's not interesting to you, but basically, if you look at the analytic solutions, what we can find are these stable solutions that have different modes. And so one of the modes for a wave in a string of chains is that it swings back and forth like this. And that's called that's mode 1. And mode 2 is one where it kind of seesaws back and forth like this. And mode 3 and 4 and 5. And so we have all these different modes for stable waveforms in a chain. Now, these are equilibrium conditions, not transients. And in the modeling world, we can, of course, deal with transients. Here's an example of, I think this is mode 5. So the WaveMaker script has various public things for how long the rope is, what amplitude, what mode we're interested in picking. And notice I have an array here so that I can actually have more than one mode simultaneously active. And I'm going to build the visualization with a line renderer. And I have the various positions, displacements, velocities, and accelerations, as well as values for the midpoint that are all just floating point values. So in start, I'm basically setting up the rope here, and the line renderer that I'm going to represent my rope with, and setting their various positions. And then I start this coroutine animate. Oh, here's initial just sets up the arrays and assigns the starting points of the rope. And there are two ways that we can do this. One, we can give it a shape that will then oscillate stably, and that's what we're doing here. We're doing the different modes and setting up the positions of our rope with that. Alternatively, we can drive the rope, which I'll show you in a minute. But animate is really nothing more than that Euler-Richardson method with the midpoint calculation, and then updating the line positions. And I don't do this every time step. I do this, I think, every 10th time step with this counter mod step equals 0. And so I'm not, this is something you do to kind of balance computational load against graphics load. So here's what that looks like. And in this case here, I'm driving one of them. The top one here starts off with a configuration and just oscillates back and forth, whereas the bottom one is being driven by this little oscillator here. This little node is being driven up and down, and it's sending waves out across the string. And so this is what mode is this? This is the wave generator is doing mode number 5. And as I mentioned, that mode is an array, so I can actually put 2 modes in here and have it do modes 5 and say modes 3. And so this is now going to make a more complex waveform, at least for one of them. Yeah, so the top there is a combination of 2 different simultaneous modes active in this string. And so, of course, don't save. Of course, I get lost in setting this thing up so that you can kind of interact with it. And there you can see, let me start that over again and do it in slow-mo. So I'll turn on damping and turn off driving so that it'll settle down again. And now I'll turn off damping and turn back on driving. And what we see is this wave propagating from left to right here. And what produces that standing wave, the mode, is that the reflection of the wave coming back off the other wall adds to the traveling wave that's moving to the left. And those 2 waves that kind of bounce back and forth in each other, if they are exactly right, form this standing wave that bounces up and down. And I've got this set up so that you can change the mode, and I have to damp this out. Let me toggle slow motion off, damp it and stop it driving. There's some of the transients that you get there. I got to damp that. So turn the damping off and turn the driving on. And now we have this mode 3 which eventually will settle down. There was some noise in there. Now, what I found kind of interesting here was that, and that's using all my numerical methods and Euler-Richardson and all of that stuff. But in this situation, my wave generator here is just making a string of rigid bodies connected by spring joints and letting Unity do all the physics. And it works. This is no numerical methods. This is Unity physics. And it's sending the wave out and it's bouncing back. And we have this established mode here. And it's all being driven by this one node that's bouncing up and down here at just the appropriate frequency to produce these standing waves. And this is all Unity physics with rigid bodies connected by spring joints, which is pretty cool. So I then carried on with this, and let me get a different game engine going here. So the next one is moving mesh. And it's really just a kind of simple extension of what I've done here. I had in 1D, I had this chain of meshes connected left and right to each other, and this made our little differential equation, and we had our numerical method that could update things. All I have to add is an up and a down spring to our already left and right springs, and I can then act on the individual masses of my checkerboard of points. And so one can use the Unity plane primitive, because we're going to access the vertices of these objects and fiddle with them. Oh, and here's where I do the up, down, left, and right. I have a checkerboard that maintains these, but it's easy. It's easy enough to have a counter, and then the edges we want to maintain fixed. So this whole if structure is just detecting the edges, and then we have up, down, left, and right as our four neighbors. So in terms of, and then calculating the forces and updating their positions. So I could do that with a bunch of rigid body objects, but of course what I want to do is fiddle with a mesh. I want to actually play with a mesh. And so from a tutorial that I've lost, it had a simple build a mesh script that in start basically made a new mesh, got the mesh filter, and assigned the vertices that are defined up here in the public variable, assigned the UV coordinates that were also defined up here, and assigned the triangles that were up here. This is basically what we need to define a mesh. The vertice positions, their UVs, which is where they get their textures from a rectangular texture object, and the vertice index numbers of the different triangles that we build our mesh out of. So with that code, here's the build a mesh, and this little mesh example has the three vertices at 5, 0, 0, 0, 5, 0, and 0, 0, 5, the UV that match these that are going to define the texture textures mapping and the triangle. We have one triangle that has 3 indices. This is one of the tricky parts, is that the definition of the triangles is a one-dimensional array where each group of 3 corresponds to the triangles. And so I run this and it builds a triangle. There it is. And its texture is mapped appropriately to lay on the triangle. So we can build a mesh. The things that we need to build the mesh. The Lost tutorial also had a move a mesh where an existing mesh that we give it is distorted by the script mesh mover. So here we're putting an object into the scene that has a mesh on it, and we're getting its mesh filter, and we're catching a copy of the vertices, the original vertices. And then in update function, I'm going through here, catching the current mesh vertices and their normals, and fiddling with the X, Y, and Z positions of those vertices, and then storing them back into the mesh. And so now we get something that looks like this. I've got these little mesh objects, and I'm distorting the different positions of the meshes within that over the time. We've got a time that's kind of defining where we're moving those things. And so what we want to do is build a mesh. The plain mesh is only an 11 by 11, not very high resolution. And so we wanted to build a mesh that looks like that plane. It's going to be an N by N grid of meshes, equally spaced, easy to lay out. So the 2 main things that we have to define are the list of vertices and the list of indices of each of that are the groups of 3 that comprise the triangles. And there are any number of ways to do this, but the way I did it was generate the vertices, assign them to quadrilaterals, because in a checkerboard we have these kind of natural quadrilaterals that have vertices at each corner, and those quadrilaterals are then easy to break into 2 triangles, and so the mathematics of setting it up kind of follows that. So here's sort of a simple checkerboard. And so my definition of the quads are going to be the 4 indices that wrap around them. And I'm doing this in a particular order. There's the winding order that is important because it defines the front and back face of our vertices. And having defined that quadrilateral as 1, 2, 6, 5, I then break this into triangles with a 5, 6, 1 for this triangle 1, and then a 2, 1, 6 for the second triangle. And notice that the winding of those was clockwise. So the order in which you define these things defines which is the front face and which is the back face of our triangle. So it's important, but it's details. So this build a plane script is going to take what my N by N is, 5. It's got a game object that we can maybe place there, and Booleans for whether we display the vertice objects, whether we animate it, debugging, and some other stuff. We've got vectors for the vertices and the vertices velocity. Those are the things that we're going to be fiddling with the physics. I'm using a vector 4 for the quads just because it was convenient. That's the one place that I figured out to use a 4 vector. Vector 3 for the tris and a vector 2 for the UV coordinates. And this one-dimensional array of integers for the triangle vertices that are every 3 correspond to a triangle. So in Start, I set this up, define the spacing, set up all the different arrays, and then go through the checkerboard and define the positions just in a checkerboard. And this counter lets me kind of maintain these things as one-dimensional arrays that while still thinking about it as a two-dimensional checkerboard, but I'm doing everything in one-dimensional arrays. Here's that little object that I'm going to instantiate. So having defined those, then I go through and define the 4 vector that represents my quads. And this is just a bunch of fiddling. There's 4 numbers here, and I have to make them match the 1, 2, 6, 5, and the 2, 3, 7, 6, and the 3, 4, 8, 7, and so forth across the different rows. And so that was some fiddling to get those, and I'm storing that in that 4 vector. Then I can go across the number of quads and break those up into triangles. One triangle is N3, N2, and N0, and the other triangle is N1, N0, and N2, where I'm pulling that out of the XYZW of my quad 4 vector. So that defines the plane. And then I need to go through and assign the triangles. And so here's my list of number of tries. This is 3 times the number of triangles. And I'm just adding the X, Y, and Z of each of these in and incrementing the counter. So this is my one-dimensional array with groups of 3 for each triangle. And now I can make my mesh, new mesh, assign the vertices, assign the UV coordinates, and assign the triangle vertices, and assign this to my mesh filter, and assign that mesh to the mesh collider, because I want to be able to walk around on this mesh or bounce objects off it or whatever. That built our mesh. Now in the update function, I want to move the vertices around, and this is just like the 1D case. I've got this spring update that takes all the moving vertices, and if I have my little game object displayed here, I can also move the transforms around, but basically, I catch the current vertices and the moving vertices, modify them with the spring update, and then store them back into the mesh vertices. And here's the thing that helps somebody, I forget who was going to recalculate the normals themselves. The mesh has a recalculate normal function that does it for you. And so the lighting is all done correctly here because the normals are recalculated. And I'm also updating the collider with this new modified mesh. I wanted to be able to interact with that plane, and so I made this little touch the mesh script that is attached to the camera. It basically has these various bailouts if we're not interactable, or if we're not pressing a mouse button, or if the raycast hasn't hit something, or if the thing that it's hit is not the mesh plane, or if the thing that we've hit doesn't have a collider, we bail. Otherwise, we access the mesh, and this is the collider. We're looking at the mesh collider. And from that, we're getting the vertices. And with this, we can access the hit triangle index. And we then have to figure out which triangle that corresponds to by multiplying by 3 and offsetting by 0, 1, or 2. And we can then take those 3 indices of the triangle that we've hit and do something with them. We add some noise to it, or well, we throw them up a little bit in the air, assign those vertices back to the mesh, assign those back to the collider, and bingo, we have something that looks like this. Here's a flat plane. Got to run it. Here's a flat plane, and there are all the little game objects that are displayed to show the actual corners of the mesh. And if I touch it, it does something to that thing. And we've got waves rolling around in here and various objects that are bouncing around on the collider. So all very cool. And here's some diagnostics up here. Energy should be conserved, and it is pretty well. Of course, when I bump it, I'm putting energy into the mesh, and so that changes the energy. Here it's kind of starting with a bowl shaped. So this is kind of one of those normal modes. Here's a normal mode 2 in 2 dimensions, where the different checkerboards are sort of rolling back and forth here. And of course, I still have access to bouncing it. I put that touch object in a bouncing object. So every place it hits the mesh, it kind of gets bumped up there, and interesting things happen as this thing rolls around, touching the mesh and adding energy to it. Here's a big spike that just kind of propagates out as a spherical wave that then bounces off the walls. And of course, one gets carried away and wants to put a character in this world here that where the world is kind of deforming beneath them. And so that was all very cool. And I had a lot of fun with that. So that's all cool. I did the job system. Let me get out of this one and get into another one here. So all that physics that we're doing in there would benefit from the job system. Those are independent operations. Each little object is looking to the left, to the right, forward and back, and deciding what its force is based on the current position of its 4 neighbors. And so we can do this in parallel using the job system. Big change here is that we have native arrays instead of vector 3s because we're going to be passing them. We want them to be thread space. We have the various jobs and handles that we're going to define here. If I'm using the burst compiler, which is great, I need that directive in front of the force job. The force job takes the positions. It's going to produce the forces. We have delta time, the object count, the number in X and the number of Y, and the spring constant. And so the execute here is just going, has the counter. This is that 1D array that goes through the different things. And this bailout here is just so that I'm not modifying the edges of my array. If we're, this keeps fixed the edges. But once I find one that doesn't satisfy all those ifs, I have my up, down, left, and right. I generate the force, and that's what gets returned. The velocity job is very simple. It's just a delta time times forces with the velocities produced and the forces as a read-only and delta time. And the position job just updates the positions. I didn't use a transform here. I could have, but this is just an iJob parallel 4 that updates the positions using Verlet method. and set up all jobs, does the scheduling here. We schedule the force job, then we schedule the velocity job to depend on the force job completion, and then we do the position job depending on the velocity job having completed, and then we check for the position job to have completed, and then we can go on. So that's the setup there. The spring update sets up all the jobs, that does all the physics, and then we return our positions, and those then get turned into mesh positions just exactly the same way we did with the other. So here, and I don't know what the frame rate's going to be like because Unity and Zoom are never very happy together. Basically, these are all just the same ones I showed you. But for comparison here, I have a 35 by 35 sequential version, and it's running pretty slow, two frames per second. I don't know if this will pick up. When I swap to the parallel job, and this is without the burst, and my frame rate basically went up by a factor of 5. Still terrible. Zoom and Unity do not get along. But anyway, I go to the burst compiler, and now my frame rate's up in the 40s and 50s, and I believe I can actually increase the resolution of my my grid here. No, it's not very happy. Run this without Zoom on your own, and you'll see the performance. And here's 51 by 51, and for some reason that frame rate went up when we moved. Something might be not getting disposed or something, but anyway, it definitely, and here's finally 75 by 75. A lot of vertices, and without Zoom running, I basically get about 5 times as many vertices used with the job condition. It's worth looking at the profiler. And I don't know how this is going to look with Zoom running. But with the profiler, I've got the scripts and physics showing here because that's the main thing that we're doing. And we'll see, going to compare here. And this is the sequential version that is clearly being flogged by both the physics and the scripts. Physics we don't have a control over, but going to the parallel job, that was supposed to go down. Well, there the burst went down quite a bit. And if I go back to parallel jobs, no burst, it's up again. And then here's the burst and burst, and run this yourself without Zoom running. Over here, if I press A and look at the jobs, you can see there's a lot of activity on the jobs here, a lot of stuff going on. And I don't know why it's not working well with Zoom, but this is a common problem. So again, physics, which is always fun, and the job system, which really works. It's one of the few applications of parallel programming that I've seen that actually does significant speed up. It's really a cool system. Any questions? No, I bludgeoned you with equations, and that always people's eyes roll back in their heads when they're shown equations, particularly differential equations and numerical methods, and oh, God forbid, but
It's scary stuff.
scary stuff. And you know, there are those little game objects in there that are matched up with the vertice positions. And given my experience with the 1D case that had spring joints just connected to its neighbors, there's no reason why you couldn't connect spring joints to all 4 neighbors and let Unity do the physics for you, update the positions of these objects, the rigid bodies, using Unity physics, and then take their positions and apply that to the moving vertices of the display of the surface there. So you could do it that way as well. I have no idea what it would look like. You wouldn't then get the, you wouldn't then have the job system helping you out, though. It would be Unity physics, which is all sequential. Wave equations bring back bad memories from physics homework. Thank you, Matt. You'd have loved my modeling class there. It was just all equations. All right. Well, we're running up on the 150. So I'm going to stop recording here.